Hey students, Alex from Mizue Education here. Today we'll be aiming to master the addition techniques within Algebra. So put on your set of headphones and let's zone in. Now before getting started into how to actually do addition within Algebra, there's a concept we need to be familiar with, and that is like and unlike terms. Now like terms consist of common pronumerals, or what we discussed in our previous video, the common letters, and they are raised to the same power. So for example, A plus A would be like terms, given that they both have the same pronumeral and they are raised to the same power, being 1 in this case. Another like term would be, for example, x cubed plus x cubed. Now in this case, these are also like terms, given that they both have the same pronumeral and they are both raised to the same power. Now what is not considered a like term would be something like this: x plus y. Now you can see that they are both different pronumerals and hence they are unlike terms. Another example for an unlike term would be something like a cubed plus a squared. Now, although they have the same pronumeral, in this case being a, you can see that they both have different powers, one having a 3 and the other one having a 2. And in this case, these would be considered unlike terms. Overall, what is important to note is in addition can only happen between like terms. Now that we've gone through the concepts of like and unlike terms, let's go through some of those high-yield question types within addition algebra. So the first common question type is something that looks like this: 3x plus 5x, where we have two numbers and we have like terms. The like terms, we can see it's shown by x and x, the same pronumeral, being raised to the same power. Now, how do we do these questions? We first need to understand that addition only occurs with like terms. The second step is to understand that whatever the pronumeral is will remain at the end in your answer as well. So in this case, you will have x remaining in your answer. After this, it's just adding the numbers. So in this case, we do 3 plus 5. That will give us 8, and then again, the pronumeral will remain, given that this is a like term. The next common question type is something that looks like this: 4a plus 3b plus 2a plus 5b. Now here, we can see that we have some like terms and some unlike terms. For example, 4a and 3b, they would both be unlike terms, given that we have the pronumeral a and the pronumeral b. On the other hand though, we can see that 4a and 2a are both like terms, hence we can add them both together. So the overall principle that gets applied here is known by grouping like terms. So there are a few ways you can do this. You can either go straight from this, or sometimes what you can do is just make it a bit more simpler for yourself. Group those like terms together just by moving things over the plus signs. For example, making it like this: 4a plus 2a, that's your first set of like terms, plus 3b plus 5b, and that's your second set of like terms. Now here, you just need to do 4a plus 2a. So we keep the pronumeral in this case, so a will remain, and we add the numbers. 4 plus 2, that gives us 6. So we'll already have 6a as part of our answer. The next bit is to focus on the other group of like terms, in this case 3b plus 5b. And here what we do, again, the pronumeral will remain, so b will remain in our answer. 3 plus 5 gives us 8, so the answer for that would be 8b. And overall, we can see we get an answer of 6a plus 8 B. The third question type is a little bit tricky. It looks at this concept, 2xy plus 4yx. Now, although at the start it may seem like these two are unlike terms, we need to keep in mind that when we have pronumerals put next to each other, it means that they are multiplying. So if I just take xy or yx out, yx is y multiplied by x. It's the same thing as saying x multiplied by y. So this can also be rewritten as xy. So if I was to rewrite this, it would be 2xy plus 4xy. So the top and the bottom are both the same. And here we can much more clearly see that these two are like terms. And the same process follows. So we can see that x and y, these are our common pronumerals, so they will remain in our answer. And then we just add the numbers. 2 plus 4 gives us 6. 6xy will be our answer. The final question type looks at something like this. 12y plus 3x plus y. Now here, it focuses on two different principles. One, let's start with the first one, grouping like terms. That is 12y plus y. These two are like terms given that the pronumerals are the same. And they're also raised to the same power, being to a power of 1, but we don't include that. Now, after we add this, we get 13y. However, we get this remainder of 3x. Now, given that this 3x is not adding to anything else that is a like term in this equation, we leave 3x as is in our answer. So in our answer, we would have 13y plus 3x, given that 3x has nothing else to add to, that is a like term. Now that we've covered the content of addition within algebra and gone through some of those high yield questions, let's go through some practice questions. Alright, hopefully you had an attempt at some of those questions. Let's go through them together. So starting with the first one, 2a plus 6a. So first, let's understand, are these like terms? So we can see that they both have the presence of a, and they're both raised to the same power as well, being the power of 1. So in this case, they're both like terms. So it satisfies for them to be added together. So given that they are like terms, the pronumeral will remain in the answer. And all we need to do is then just add the numbers. So 2 plus 6 gives us 8, and then keep the pronumeral in our answer. So overall, the answer would be 8a. Now let's go through the second question. The second question, now looking at this as a whole, we can't just add them all up straight away. And we can see that we have some like terms, some unlike terms. So let's kind of group them together. So the first step, by grouping our x's together, we get 5x plus 6x plus 3x. So let's write that down below. 5x plus 6x plus 3x. So that's our first group of like terms. The second group of like terms has y. So 3y and 2y. So plus 3y plus 2y. And that is our second group of like terms. And now we can add those respective like term groups in their own separate groups. So starting with 5x plus 6x plus 3. 5x plus 6x gives us 11x. 11x plus 3x gives us 14x. That's half of our answer done. The second half is looking at the y's. So 3y plus 2y gives us 5y. And that would be the answer. Now, looking at question 3, we have 11ab plus 2ba plus 3ab plus 2a. So let's first identify where those like term groups are. So first off, it may only seem like we have 11ab and 3ab as our like terms, but don't forget we also have 2ba as a like term to these two. That's because ba can also be written as ab. Okay, so here we do 11ab plus, you can imagine 2ab plus 3ab. That gives us 13ab, 16ab. So 16ab, that's our first group done over here. And now we can see we have this remaining 2a. Now the 2a doesn't have any other like terms it can add to, so we just leave it as is in our answer. That is question 3. Now moving on to question 4, again, same strategy. Let's identify where those like terms are. We have a 10x, a 3x, and an x. These are all like terms given they are the same pronumeral to the same power. Let's group them down below. 10x plus 3x plus x, that's our first group. The second group, let's have a look at the a's. So we have a 5a and another 5a. Let's group these two together, 5a plus 5a. And then we can also see this plus 2. Now this doesn't have any other like terms, so in our answer, most likely it will remain as is. Okay, now let's simplify this a little bit more. So 10x plus 3x gives us 13x. 13x plus x will give us 14x. That's our first part of the question done. The next bit, 5a plus 5a, that gives us 10a. And finally, we have this plus 2. Again, doesn't have any like terms, so we just leave it as is in our answer. Alright, hopefully you found that helpful and have got some gains in addition algebra. And if it was helpful, comment in the chat. This is Alex signing off for now. See you all on the next one. Stay sharp.